OC or this is PC here. So okay, OC I have taken. So if I take the other triangles, which triangle is OLC, the smaller triangle here, OLC, okay, then OLC, OL upon LC in terms of side of the triangle. This is A by, this is suppose total length is A here, okay. So there can be other values also, okay. So this value, one of the value of the ortho center from the vertices we have taken out, we have calculated. This is one of the values. Okay, so ortho centers value. Now if I take this in another way, there is one more value given. Okay, LBP angle is what? LB. Now in terms of this angle LBO. Now in terms of angle LBO, if I take, and what is the value of BL or OA, okay, OL, we have taken OL, length of the OL and BL. If I take BO, the length of BO in triangle OLB, so in that way, in triangles in tangent form, if we calculate, it will be in terms of cot C, it is also coming. So BL upon 10 angle LBP, LAB we have taken. So BL into okay. Now if I take, there is another formula can be obtained. Now let me just take another form of this. What is that another form? Now if I take OB, the length OB suppose, or OA, whatever, I'm taking here in the below circle, sorry, below this triangle OBL, in a right angle triangle OBL. This is OBL. What do we have? OB we have to find out. So OB is equal to, okay, so BL upon OL. So OL, if I take, what is OL here? If I take OL is the angle opposite to this angle OBL, okay. In terms of angle OBL, this is perpendicular, this is base here. So BL is equal to how much? So BL upon OL in that situation, this is BL. So BL upon OL, because this BL is base, this is perpendicular, it will be cot of, this angle will be cot of B here. I'm sorry friend, this value we have to calculate. I'm taking this triangle O or PBL. If I take this angle OBL, cot of angle OBL of angle OBL, this is angle OBL, okay. So cot of angle OBL we have taken here. What is this angle OBL? Now this is orthocentric. Okay, now if I take this right angle triangle in C, this angle OBL will be 90 minus C angle. Try to understand. Why? Because this is right angle. It will be angle OBL in terms of this, with BL upon OL. We have calculated value of BL. BL is equal to, therefore, OL into, this is OL, into cot of 90 minus C. Sorry, this is 10, I'm sorry. But perpendicular upon, this is perpendicular upon OL upon BL we were taking, which was cot. I'm sorry. This is OL upon BL I'm taking. This is OL upon BL. So this is cot. No, this is 10, sorry. 10 of perpendicular upon base, let me take. This 10 of angle OBL, but angle OBL in this right triangle OBMC is 90 minus C angle. This is 10 of, sorry. So we have obtained here OL is equal to, therefore OL is equal to this BL into 10 of BL into 10 of 90 minus C. Try to understand. Why 90 minus this is C angle, this is right angle, BMC, sorry. BMC we have taken BL 10 90 C. So this is BL. Now BL is now this BL in this triangle we will find out BL, what is the BL value. But before that, this BL are taken here. Sorry. So this is BL into 1090 minus C is cot C. Try to understand. So this is cot C. So OL is equal to this OL I have calculated because OL is AL minus OE. So OE will calculate after that. What is OL? With this OL we are calculating. OL is equal to BL. Now BL is what? This is cot C we have taken. BL upon OA, OL, or we can take AB here. BL upon AB because this angle B we are taking. BL we have to find out BL upon. Let me take what is BL. So BL upon OAB, sorry, AB is side C. This is AB here. So BL upon AB. So this BL angle we have taken this. So this is base upon hypotenuse. This is cot B. Sorry, cos B. This is angle B here. This is cos B. Cos B we have taken. So this is base side opposite. This is AB. This perpendicular there. Okay, so in that situation, this is AB. So BL equal to AB cos C. Sorry, let me calculate this separately. It was here BL into cos C it was. Now here I am taking. So what is BL upon AB? BL upon AB is BL upon AB is base upon hypotenuse is cot B angle. Cot B, sorry, cos B, I'm sorry. This is cos B here. So BL therefore is equal to AB is small c, with small c, AB, or let me first write AB into cos, AB into cos B. This is AB into cos of angle B, this angle B. AB is a small c, this is cos B. C into cos B angle. Okay. Now this OL, sorry, BL, this BL now in terms of this AC if I take, so in place of BL if I substitute here, it will be cot C. Therefore OL is equal to, we are calculating, therefore OL is equal to BL, now BL is AB into cot B, cos B, sorry, AB into cos B into cot C, AB into cot B into cot C. Now what is AB here? AB is small c, so this is C into small c into cos B into cot C. Try to understand. This is value of OL. This OL here we are calculating. Let me write here. So other than those three formulae for the value of the orthocenter from the vertices we are calculating, then we will calculate what is OA, that we will calculate it. But here OL we have taken out. Okay, so this OL we are calculating is OL is equal to C into cos B into cot C. Is the value of OL, but OL is AL minus OA we can take, or if I calculate this OL in other terms, means in terms of this BL we have taken the C into sin C, so BL can be taken as, or OL if I take, or in terms of BL, if I take AO, because OA we have to find out. Okay, so now this is the distance of the L from center O, from ortho center. With the value of ortho center we were calculating. So here OL we have calculated, this is C cos B into cos C. So similarly, other things can also be calculated. Now, but this is okay. So cos B 90C. So C cos B, but C is okay. That can be written down here. Now, but this value was of OL. OL is here. This length here. This can also be taken out. Suppose we have to find out what the distance of this point L, which is the point meeting the perpendicular meeting on the side BC, okay, of the angle A. So this OL distance we have calculated. OL we calculated there, and OL is this. OL is C into cos B. What is value of C? Small c. Small c is twice R into sin C, triple C, and into cos B. This is into cos C means cos C upon sin C. This sin C cancel out. This is nothing but twice R into cos B into cos C. So twice R cos B cos C is the value of OL. Twice R cos B cos C. This is opposite to this side vertex A. This OL is calculated as twice R cos B cos C. Similarly, ON and ON can be calculated. What will ON and ON? Let me note down that also. Similarly, we can write the values of orthocenter's distance. For the value of orthocenter, distance of the orthocenter from the vertices A we have calculated, OA we calculated. Now we are calculating what is OL here. So this distance OL and OA will make this whole length of the perpendicular. This length of the perpendicular in that situation. So now OL we have calculated. What is OM? Now OM is opposite to angle B, and this was OL was opposite to angle A. This was in other than angle A. So this will be twice R. OM is twice R cos A into cos C. Try to understand. In this case, other than B angle will come out. Here it was other than angle A, cos B cos C, twice R. Similarly, this is OM was opposite to angle B. Okay. So similarly, ON and ON is equal to twice R into cos B into cos A. Let me take first cos A. Cos A into cos B other than angle C. This is value of OL. So length of the orthocenter from the from the vertices we calculated, and from the opposite sides also we have calculated. O, distance of O from the L point from M point to OM, OL and ON is also calculated. These are the three other values of the orthocenter. Okay, the distance of the orthocenter from the two sides. 2R into cos A cos B, 2R into cos A cos B, length of ON, right, and PN also we are calculating. Now let us take question number 4. In question number 4, we have to prove that circumcenter, centroid, and orthocenter are collinear. What is centroid here? Centroid is the incircles point, the center of the incircle, centroid. Okay, the circumcenter are the same thing. Okay, so that we have to prove after 5 minutes time, because our camera is going to be full. So let me take that separately. Now question number 4, which I have to prove. Question number 4, let me take. First let me clean this. have to prove that these are the collinear, orthocenter. Question number 4. Prove that circumcenter, centroid, and orthocenter are collinear. Means they are collinear. They are passing through the same line. Collinear, line on the same line. That we have to prove. Okay. Let me change the marker I've taken. Second marker I've taken. Let me clean this. Question number 4 I have to take here. Question number 4. First, let me note down that, and after noting down, I'll do it later. But I have to prove that they are collinear, or that these are lying on the same line. Orthocenter, circumcenter, and centroid. So that we have to prove. Question number 4. Let me take to prove that orthocenter. First is circumcenter. To that circumcenter, okay. Centroid, and orthocenter. And orthocenter are collinear. They are collinear, lying in the same line. Okay, they are collinear. This collinear word is lying on the same line. We have to prove. Okay, so if I take, let me take a triangle ABC. If I take this, this is the point, and this other point. These are 3 points here. Now these three points we can take. If I take them as, this is O point. Sorry, let me take O point here. This is P point, and this is G point. Third point. Okay, so if I take this point, and this is the perpendicular. This is orthocenter. Perpendicular. If I take this as, okay, and now G is centroid we can take, and this is orthocenter, and P is another point here. Let me take what are P and G. We will prove that this O, G, and P are collinear. It is A, B, and C points. If I take this as D point, okay. So, and this is a right angle. If I drop the perpendicular, what we have to prove here, that orthocenter. Now space is not there in the camera, so I'm just taking this leisurely. Question number 12 here. Okay, so in this triangle we have to prove that. Okay, now this we have to prove, and this is the perpendicular. Let me take this L point here. A, B, L. This L is the midpoint of. We can take the perpendicular to this space here. So this is perpendicular here, and this OD is perpendicular to this. Okay, so APL we have just taken this point. Now here I am not taking this point. I am not taking here. I'll just take that what is the point here. If I prove that two triangles are similar triangles, and what is O here, what is G, what is P. These three things are taken. P is maybe orthocenter, this is the orthocenter, G is the centroid, and this is the circumcenter. O is the circumcenter. Let me take circumcenter. Circumcenter means the center of the X, the circumcenter. The circle is passing through all the 3 points. So how do we obtain these 3 points? After that, we'll prove that this O, G, and P are lying on the same line. They are pulling here. But this I'll take after 5 minutes time because camera is full. Okay, so that let me first bake it. That is there. Okay, so this all these 3 things we will take. Okay, after 5 minutes, we have proved that O, G, and P, where P is the orthocenter, G is the centroid, and O is the circumcenter. Circumcenter, orthocenter, G centroid, they are lying on the same line. This we have to prove. Okay, that I'll prove after 5 minutes time. Okay, then see you after 5 minutes time, please.